Hello, my name is Steven Sines. I am the STEM coordinator at the Grand Prairie Collegiate Institute, and today I'll be giving you instructions on how to judge the Can in the parking lot Lego competitions for Stemposium. They are pretty easy to judge, and the instructions that come with them are quite self-explanatory, but this will give you a visual look at how you will be doing it on the day of Stemposium. If you have any questions, feel free to email me at steven.sines@gpist.org.
This is a typical robot, and all robots must be able to fit within a 12 by 12 inch cube. So measuring from the back to the front, this one is about 10 inches. From side to side, we include the wire that is sticking out. So this one is about 8.5 inches that way. And then you also include how tall it is, and all that needs to be less than 12 inches to begin with. For the can, all the cans are going to be set up equidistant away. So as you can see, they go from straight across at 45-degree angles as you move around. And each one is about a 1 inch away from the inside of the black border. When the team is ready, they will place their robot on the inside of that circle. There's a small X there. They can face it any direction they want to, and their time begins when they press the button in the middle to make it run the program. As it is going to the program, the idea is to push the cans outside of the black line all the way without actually touching anything on the black line or outside. So as you see, the light sensors do go beyond the line, but the tires do not touch, and that is good. If, on the other hand, their tires do touch, they will be penalized the 5 seconds that is required for that. The goal is for them to push all the cans outside of the black line so that they are not on the black line at all anymore. It's okay if they knock them over, push them out, whatever, as long as they are out of the circle, they're good. With the parking lot, as you see, it is set up with a black wall on the top side with 4 Lego barriers going down the side that are going to be 2 studs wide and 32 studs long. Those barriers are to be measured so that the middle of the black line is 6 inches and each of the middle of the Legos is going to be at 0 and 12 inches. And so those need to be measured each time to make sure they're in the correct place. When it is time to run, we will be placing 2 walls to block off 2 of the parking spaces. That can be done randomly, or you can choose to do it the same way each time. The robots are set up so that they are within the mat. On the real one, there is a black line there that designates the starting point. And the robot travels and turns and goes into the parking space. In order to get the points that are required, it needs to be beyond that black line. And the black line is 3 inches away from where the wall is. So any piece that goes beyond that black line makes the robot in base where it needs to be counted, and that's good. So right there, that is good. Right there, not so much. And so that's what they're trying to go for. Definitely the wall needs to be adjusted to make sure it is in the right spot so that they can be scored appropriately. And as long as there is something that is beyond the 3-inch margin, they are good. If the robot hits the wall, that is going to be a penalty, as well as if the robot hits the borders or hits the blocking walls. Those are also penalties. The robot can also not come off the mat to touch. It may, however, have pieces that float over the edge of the mat as long as the points of contact are still within the borders. The way that this is designed, there are 3 different ways this could go with the first parking space, second parking space, and third. If the first parking space is where they have to go, whatever their time is their time. the second parking space, they'll actually get 3 points back or 3 seconds back, and the same thing, there would be 6 seconds for the third parking space because it is further.